Here's the warm-up, so you can pause the video and do the warm-up. Be about 5 minutes. So go ahead and pause it now, and then come back in 5 minutes once everybody's turning in and start. Okay, so you're asked to find the product, right? So we've been practicing these for a couple weeks now, right? So we can FOIL, you can distribute, or you can make a table. So the answers to these should be x squared minus 2x plus 3x minus 6, and then you combine like terms, so you get x squared plus x, because negative 2x plus 3x is x. Okay, so that's your final answer for number 1 there. Number 2, you get x squared minus 6x minus 4x. This time when we take a negative 4 times negative 6, we get a positive. Negative times negative is a positive. Positive 24. Now we combine like terms, we get x to the, did I say x to the 4th? Oops, sorry. Back here is x to the 2nd. Because x times x, like we've been preaching, is x squared. So we get x squared, negative 6, you borrow $6, you borrow 4 more, that's negative 10x plus 24. So that's our final answer for number 2. Now we're going to factor the polynomial. Okay, factor means that we're looking for what times what equals this polynomial. Okay, so we're kind of going backwards, all right? So you might not have done this before, so you probably had no idea, and here we're going to go ahead and I'll do it for you. So you can put it inside the box. This time we're going backwards. We want to find the sides of this this rectangle. Okay, so we know x squared goes here, and we know negative 6 goes here. Okay, now we can find the sides, right? This times this gets me the inside of this box, so that's x and x, because x times x is x squared. And then we know the sides of these two get me negative 6. So that could be a 2 and a 3 get me 6, but is this negative or is this negative? Or is this positive and this one's negative? So it depends, right? Because these two middle, we know always add up to what our middle term is, negative 5x. Okay? So here, if I have a negative 2 here, that's a negative 2x, and this would be a positive 3x. Those don't add up to, as our example from up here showed, those only equal x, right? So I got to erase those. Those aren't going to work, so I can't do a 3 here. Can't do a 2 here. How about switching them? How about doing a negative 2 or a positive 2 and doing a negative 3? So that would be a negative 3x and a positive 2. Well, that's just going to get me a negative x, so that's not going to work either. Well, what other, is there anything else I can multiply to get to 6? So 2 and 3, anything else? Oh, what about 6 and 1? Don't always forget the number in itself. Now I need a negative 6. So maybe the negative 1 and a positive 6. So that will get me a 6x and a negative 1x. So then here we have to really practice on adding numbers, adding negatives, subtracting, stuff like that here. All right, so 6x minus x, that is 5x, not negative 5x. So since I need to switch the sign here, then I need to switch this sign. So, okay, so I switch the sign here and switch the sign here. So here we get a negative 6 and a positive 1. So positive 1x and a negative 6x, that indeed equals that. So now we look at our factors. That would be the sides of the polynomial, x minus 6 and we write it in factored form, x plus 6. Factored form is just taking your two factors, your two sides of the rectangle, and multiplying them together. We don't literally multiply them together. We just write the two factors down next to each other by parentheses. So that's our answer to number 3. This is definitely new to you, so we're definitely going to be going over it quite a bit. Another way to do it's called a cap, and I'll explain that at some later date. But right now here I have another 2 by 2. We have 2x squared this time, and we have a 3 here, and then these two middle are going to add up to 7x. So now we have to ask ourselves, okay, what times what gets me 2x squared? I know that's an x and an x, but where does that 2 go? Does it go on top or on bottom, or on the side? Let's put it on top. Now how do I get 3? Well, 3 can go on top or it can go on the side. Let's put this one on the side. And then if I put 3 on the side, that means 1 goes on top because 1 times 3 is 3. Excuse me. So now we can figure out this and see if it gets to 7x. Well, 2x times 3 is 6x, and x times 1 is x. And these add up, well, 6x plus x is 7x. So that was a positive 1 and a positive 3. Now we can write our two binomials, 2x plus 1. Doesn't matter which one comes first, really. And an x plus 3. And that's the factors of 2x squared plus 7x plus 3. So it's definitely new. Don't worry. We're going to take a lot of time on this. So to start, we first have to take our standard form, right, the largest exponent first, and look at the degree. And the degree is 2. So that is called what we call quadratic, right? We already know that from before. And the standard form of a quadratic, you want to make sure you put this in your notes. The standard form of a quadratic is ax squared plus bx plus c, where a, b, and c are numbers. Those are called our coefficients, right? And we usually call c the one without the variable. That's the constant. I've mentioned this a few times. And then the letters out front here, those are called coefficients, which it says right here, a and b are called coefficients, numbers in front of the variables, and c is called the constant. If there is no number in front of the variables, then there is a 1, right? So if I just have a plain x, that means there is a 1 there, right? When I just have x squared, there is a 1 in front of that, okay? If there is no variables, like say it's just x squared plus 7, then this would be our constant, and this would be our quadratic term. Okay, then I would have no b. b would equal 0. Now remember, a, b, and c are numbers. They are numbers. Okay, they don't, my b doesn't have an x in it. My a doesn't have an x squared in it. A, b, and c are just numbers. Okay, just numbers. Okay, so here are some examples of quadratic equations. So we have x squared. That's the basic type of quadratic in standard form. Then we have, say, x squared plus 7, like I said. That would be, there's no b there. Okay, then I could have x squared plus x. That would be another quadratic, right? Here I have my a is 1, my b would be 1 too, and I would have no c. Okay, and then we get something like this, 3x squared minus 5x plus 3. That'd be a quadratic. Anything that has the degree of the polynomial would be 2 is a quadratic. Okay, so it can be the most basic type with just a plain x squared. It could have an a and a c, or it could just have an a and a b. Any kind of mixture. It can be a negative coefficient too. That's fine as well. Okay, so that would be one. Anything with a squared, a degree of 2, right, is called a quadratic. Okay, so the best way that I find, you can still do the box method, but the box method is a lot of checking and guessing. We don't always necessarily want to check and guess. If you're good at it, that's great. Do the box method. I don't care. Whatever way is best for you. You can look YouTube videos. There's plenty out there that show you different ways to do it. I do a thing called CAP because this is ax squared plus bx plus c, right? So I label my a is equal to 1 here, b is equal to 8, that's my linear term, so this is my quadratic term right here. This is my linear, so this is the quadratic. This is the linear term, right, because it just has an exponent of 1, right? The degree of this monomial is 1, it's linear. This degree of this monomial is 2, so it's a quadratic, and this degree is 0, so it's the constant, right? Talked about this last chapter. So there's my a1 because I have 1x squared. I have 8x, so 8's my b, and then c is my constant 15. So what I do is a thing called CAP, C-A-B. And I put a line here and a line there. And then this is, whenever we have letters by each other, it's multiplication. So if you want to put a little dot there, go ahead, that's great. That lets you know that I'm going to take my c times my a. So I want to multiply my a by my c. So 1 times 15, that is 15. And then I'm going to write my b down on this side, 8. So you have your CA, you have your b now. Now here might be a little bit hard part. You got to think about what times what? So what numbers can I multiply together to get to 15? So that's to equal what times what equals 15. I'll look a little smiley face there. And then those two same numbers have to add to equal 8. Okay, so what times what is 15 but adds to 8? Think about that. How about 3 and 5? Because 3 times 5 is 15, and 3 plus 5 is 8. So those are my two factors. So I write in factored form. I have x plus 3 and x plus 5. That's how I write my factored form. Because remember, I'm timesing first times first and last times last. If you want to, you could draw the box. Okay? And you could put your x squared here, and you could put your 15 here. And then you can say, okay, you can do the same cap thing and say, okay, what times what gets me x squared, right? X and x, and then you can do your cap, and then you have your 3 and your 5. So you can put a 3 here and a 5 here, and it's positive. So then you can see you have your sides, which is your two factors, x plus 3 and x plus 5. Now the only trick is with the cap is you have to make sure you have to divide this by your a, but our a is 1. So when I divide by 1, that's really not going to change anything, but it's going to come later on in the next section, okay? So we just want to make sure we practice that now. So then when it comes up later, we'll know what to do. So there's the factored form of x squared plus 8x plus 15, because factor is asking for what times what gets me this, right? We kind of practiced about the GCF, but now we're looking at actually a trinomial, factoring a trinomial. So we're asking what times what gets me this? Well, that is multiplying this binomial times this binomial. Those are the factors of the x squared plus 8x plus 15. Okay, so go ahead and try this one. R squared, x squared, whatever your variables just are. Okay, so go ahead and try this. Pause the video and try it. You can try to do the box if you want to. You can try to do cab, or you can try to do a combination of both. Whatever, try to work for you. Basically what you're asking is, these ones are a little bit easier, but what you're trying to do, to think about the box way, you're trying to think, you have r squared here and you have 24 here, so you're asking, what times what is 24, but those same two numbers need to add to your middle, right? These two middle ones need to add to 11. So what times what is 24 and adds to 11? That's the same thing you're kind of doing with cap. Right? C times A is 1 times 24. Your A is 1. Your B is 11. It's a good thing to practice this too. Label your A, B, and C. 24, then 1 times 24 is 24, and your B is your linear term with the R. Not just always your middle, whatever's in the middle, but it has to have your linear, your R attached to it, or your X. Okay, so that's 11. So I'm asking what times what is 24, but also adds to 11. Same thing as the box. They're really doing the same exact thing. So that would be 6. And well, you can pause the video if you need to. Okay, so you can try 6 and 4, right? So 6 and 4, but 6 and 4 multiply 24, but 6 plus 4 is not 11, right? That's only 10, so it can't be 6 and 4. So we got to try again, and that's okay. You just keep going. Well, what about 2 and 12? Well, 2 and 12, they add to 13, close, but not quite. Okay, so I can't do 2 and 12. Anything else? What about 24 and 1? Always try the number and 1. Nope, that's not going to work because that's definitely not going to add. How about 8 and 3? 8 and 3. Hey, look, 8 times 3 is 24, and 8 plus 3 is 11. So those are my two, so 8 and 3. And then what gets me r squared? R and an r, and it's a positive 8 and a positive 3. So there are my two binomials, 8 plus r plus 8 times the quantity r plus 3. That's factored form. Write it as your two sets of binomials. Okay, so you've been noticing we're factoring where it's just having x squared, where basically our a is equal to 1, which is really nice. Those are a lot easier. Okay, but here's a little more trickier one. So our a is equal to 1, but this time our b is equal to negative 11, and our c is equal to 24. So again, our a times our c is 24 again, but this time I have a negative b. So this time I'm asking myself, what times what is 24, but what plus what is negative 11? So that's going to be definitely tricky, a lot trickier than the other ones. I can explain how to do it, but sometimes you still might struggle with it. You just got to do more and more practice. What I like to do is I don't focus on this negative as much. I just focus on that 11, right? So what times what is 24 but adds to 11? So whenever I have a positive CA, then I don't care about this negative to begin with. Okay, so as long as this is positive over here, I don't really care about that negative as much. Okay, so again, that's 8 and 3, because 8 times 3 is 24, but 8 plus 3 is 11, right? We get 11, but we need negative. So if I change this to a negative, what do you think I should do to this 8 and 3? Well, I'm going to change them. So I'll change those to both negative, because a negative times a negative is a positive, but a negative plus a negative is a negative, right? Because I'm borrowing $8 and I borrow 3 more, that means I still owe more. I owe more. I owe negative 11. So negative 8 and negative 3, and then what gets me x squared? X and x. So now I have my two binomials, x minus 8 and x minus 3. So there's my answer. You're all done. If you want to check this, if you multiply these, that's what factors mean, right? What times what times what, two binomials, get this trinomial. Well, aren't you multiplying here? So you could literally multiply this out to check it, and if you got this back to that, you know your answer was correct. Okay, so go ahead and do this one. So your CA, right? Find your CA. So label your A, label your B, label your C. Take your C times your A, and label your B, and then go ahead and try to do this. Okay, your variable is y. Go ahead and pause the video, try this out. All right, so here we go. So this time our CA, our A is 1 again, and our C is 8. This time our B is negative, so it's the same kind as before. Okay, since our CA is 8 times 1, that's a positive 8. So if you want to put that positive, that's fine. But our B is negative. So once again, because this is CA is positive, I don't really care about this negative to begin with. I'll deal with it later. So I ask myself, what times what is 8? But then what plus what adds to 6? Right? So again, you could draw your box 2, just so you have it. You have a y squared, and you have an 8. So we know y times y is y squared, so we have that. Now we need to figure out these two sides. Okay, and that's where I look at my cap. So I could go 2 and 4. Oh yeah, 2 and 4, right? Or 8 and 1. Or that's it, right? 2 and 4, 8 and 1. Well, 8 plus 1 is 9, so I'm going to get rid of that. But 2 plus 4 is indeed 6. Okay, so I found my two numbers, but now here's where that negative comes in. Okay, so 2 plus 4 is 6, but I need that negative 6. So if I want to change that to a negative, what do you think I should do to this 2 and 4? Change both of them. So a negative 2 and a negative 4. I borrow $2, I borrow 4 more, that's negative 6. So now I have my two sides. That factor and this factor. There, I factored it. All done. You can if you FOIL this out or distribute or use a table, right? If you complete this table up here, if you complete it, you would get back to that. All right, here we go. This time our C is negative. So our A is 1, B is 2, and our C is negative 15. Okay. All right, so now we can do the table. We can draw it out. We have an x squared and we have a negative 15. Okay, here's where it's definitely a lot more trickier, okay? So we can do our CAB, C times A. So 1 times negative 15. Negatives are very important, right? So it's a negative 15, and our B is positive 2. Okay, here, since this is negative, this is going to play a bigger role. It's going to change things a little bit from our other ones. So we're still asking what times what, okay, is negative 15. But then we're going to go what minus what is negative, or is 2, okay? So this time, since CA is negative, that means we're going to be subtracting these two, okay? So I'm going to ask myself, what times what? Well, I can really ask myself, this negative plays a role, but I can just ask myself, what times what is 15? Okay, so what times what is 15? But those two numbers now subtract. Because the CA is negative, they're going to subtract to 2. Okay? So what times what is 15? Okay, so you can do 15 and 1. You can do 3 and 5. Let's do 3 and 5. So 3 times 5 is 15. This 15, we'll deal with this in a little bit. But now do they subtract to 2? So there's two ways to write this. Right? I always put the bigger one first. Always put the bigger one first. We can adjust later, okay? Because we all know how to take 5 and subtract 3 and get 2. So look, I got 2. Okay? So I got 5 and 3. But where's that negative? What number is that negative in front of? It's in front of the 3. Okay, so that means this needs to be negative, and that would create a negative 15, right? Negative 3 times 5 is a negative 15. So that negative is going to stay with that 3 because the negative's in front of the 3. And then the 5 here, and then what times what is x squared? Well, that's x and x. So then I have my two binomials, x minus 3 and x plus 3. All right, plus 5, sorry. And there it is. If you FOIL this out, you'd get back to that answer, right? You can kind of at least check a little bit. X times x is x squared, and 5 times negative 3 is negative 15. And then you could finish this and make sure it equals 2x. Okay, so now we're looking at when our c is negative. So go ahead and pause the video and try this one. Okay, and then I'll complete it. My a is 1, my b is 9, and my c is negative 36. So I take my c times my a. 1 times negative 36 is negative 36. Right? Make sure when you're multiplying, are you multiplying two negatives? Are you multiplying two positives? Are you multiplying a negative and a positive? Right? So those are important. I get negative 36, and my b is positive again. Okay? So again, you can draw the box, help you out a little bit. N squared and negative 36. You can ask yourself right off the bat, what times what is n squared? N and n. Okay, now we need to complete these two. Complete this one and complete this one. So again, we'll focus on this negative later. What that negative kind of indicates is that we're really going to be subtracting these numbers to get to 9. Okay, and then we're multiplying those numbers to get to 36. Okay, so just think about what times what is 36. We'll deal with the negatives in a little bit. Okay, so what times what is 36? Well, that's 6 and 6. But is what's 6 minus 6? That's 0. So that's not going to work. Okay, let's try a different one. What about 18 and 2? 18 and 2, that's 36. But what's 18 minus 2? Always put the bigger one first. That's 16. So that's not going to get us there. What else is there? 9 and 4, right? 9 and 4. That's 36. But what's 9 minus 4? That's 5. Is anything going to work? 36 and 1? So 36 and 1, 36 and 1, 36 minus 1, that's 35. I guess nothing's going to work. I guess not, so I guess it's not factorable. Oh, wait, yeah, what about 12 and 3? Let's do 12 and 3. What's 12 times 3? 36. And then take your bigger one minus your smaller one. Hey, that's 9. All right, there's our numbers, 12 and 3. So 12 minus 3 is indeed 9. Now, where's that negative in front of? It's in front of the 3, right? So let's put it in front of the 3 here, and then we get negative 36. So it's a positive 12 and a negative 3. Now I can write my binomial, n minus 3 times n plus 12. There is my factor. Oh, make sure you put this in parentheses too. Okay. Okay, so we're talking about area. Right, we're applying it here. We're pretty much going to do the same thing, factoring as what we did before. Of course we are. It's just another applying problem, right? But we're still going to be factoring this polynomial. So the area of a rectangle is given, right? So we have this rectangle, and our area is given. We have an x squared and a negative 35, and then these two areas will equal negative 2x. It's the same thing we're doing, right? So we could do cab. There's our box already set up. We can do cab. Right? So I ask myself, what's my A? What's my B? Remember, they're always just numbers. They don't have any x's in them. And C is negative 35. Now I can take my C times my A. Negative times a positive is a negative. So we get negative 35. And our B is negative 2. This time's a little bit different, right? Okay, here what we're going to do, again, the CA is negative, so that means I'm really going to be subtracting two numbers. Okay, and let's go ahead, and then we'll multiply to get to 35 for now, and then we'll subtract these numbers and get to just positive 2. We'll worry about this negative a little bit later as well. Okay, so let's just think about positive 35 and then subtract a 2. So what times what is 35? So that's 35 and 1. And they multiply to 35, but they only subtract to 34. What about 7 and 5? 7 times 5 is 35. What's 7 minus 5? Hey, that's 2. Okay, so 7 and 5, and then always put the bigger one first. 7 minus 5 is 2, but we need a negative 2, right? We need a negative 2. So if I switch this to a negative, then that means I'm going to switch these spots here. I want to switch them spots. So I want to put the 5 in front this time. I want to put the smaller number in front, followed by the bigger. Now what's that sign in front of? It's in front of the 7. So over here I want to put it in front of the 7. So then our sides are negative 7 and positive 5. And then what times what is x squared? Well, that's x and x. So we have x plus 5 times x minus 7. And again, you could multiply those two binomials out, and you'd get back to our original answer of the x squared minus 2x minus 35. You could do a little bit of check. X times x is x squared, and then 5 times negative 5, that's negative 35. So at least I know everything but the middle, right? So I know I'm pretty much on the right track. And if you fill in this box, you get 5x here, and you get negative 7 there. And then that's going to equal negative 2. So we're correct. So there's our answer in factored form. Okay, again, you're asking to find the dimensions here. You can pause the video if you want to, and basically you're going to factor this, right? There's our area, x squared negative 72, and then these two add up to negative x. And we're finding the dimensions. Well, the dimensions are just asking for the factors, right? What are the two binomials? That's what it's asking for. So you can go ahead and pause the video and try it. So again, we can do CAB. You can label our A as 1, our B this time. This time it might be a little tricky thinking about your B, but it's a negative x, so that is a negative 1. Not a negative x as your B. Your B never contains an x, right? If there was no x's there, if it was just x squared minus 72, then your B would be 0, but it's a negative x, so your B is negative 1, and then C is negative 72. All right, so again, we can multiply C times A. Negative 72 times 1 is negative 72. And our B is negative 1. That's going to be a big kind of probably trouble there. So make sure you have negative 1 x's, right? And you have 1x squared. So your A is 1, your B is negative 1. All right, so now we're asking ourselves, this is negative, right? CA is negative, so that means I'm really going to be subtracting here. And let's not think about this negative on the B yet. Let's just think about positive. And then let's think about multiplying two numbers, and let's get a positive 72. So what times what is positive 72, but what two numbers, those same two numbers, need to subtract to 1? So 72, there's a lot there, right? 36 and 2. There is, what, 4? 4 and 18, right? 4 and 18, you can keep on going. You could just take 72 and start dividing it by 1. 72 divided by 2, 72 and divided by 3. See if it goes into it evenly, right? This does its 1 and 72. This does its 2 and 36. What about 3? Well, 3 goes into it 2 times there, yes. So 24, right? 24. So those are two factors, so 3 and 24. Then I can do 72 over 4. Hey, that's what did I say, 18, right? So 4 and 18, and you can just keep on going. And then 6 and 12, right? 9 and 8, and you keep going all the way till you start repeating itself, right? So there they all are, 4 and 18, 6 and 12, right? If I'm 6 feet tall, I'm 72 inches tall, and then 9 times 8. So which one of these subtract to 1? So basically, which one of them have a difference between them is 1? Not that one. Not that one. 24 minus 3 is not 1. 18 minus 4 is not 1. 12 minus 6 is 6. Hey, 9 minus 8. 9 minus 8. 9 minus 8 is 1. And 9 times 8 is 72. Now we can deal with these negatives. So 9 minus 8 is 1, but we want a negative 1, right? So that means that I need to switch these two. This needs to be a 8 in front, put the smaller number in front, followed by the bigger number. So that means the negative is in front of the 9, so I need to put a negative in front of 9, and that equals a negative 1, and negative 9 times 8 is a negative 72. So we have negative 9 and a positive 8. And then what times what is x squared? X and x. So then we have x minus 9 and x plus 8. That is our factored form. So this video is getting a little long, but that's okay. It might take you a few days to go through this, and that's fine as well. You can always fast forward as well, and or you can just print off the notes and then come back to wherever you're seeing that you're struggling. You can just fast forward the video to the parts that you're struggling at. Okay, this is definitely going to be hard. So you're doing two variables this time, okay? So you're doing two variables this time, so it's a little bit difficult, but that's okay. We can label our A as 1, our B is 6, and our C is negative 55. Okay, so here definitely you probably want to do the box. Okay, so here we have an x squared, and then on the bottom we have a negative 55y squared, and don't forget the y squared in here. Then we can ask ourselves, what times what is x squared? That's an x and an x. And then down here we want to ask ourselves, okay, don't worry about the 55, but what times what is y squared? That's a y and a y. So then if I start multiplying this box, I can see that I get x times y. This is an xy. And here I get an xy. Notice that these terms are the same, so we could add them, right? And they would give us some sort of xy. Right? Because I'm getting some number here and some number here. And then we're going to get a total of 6xy. So that means that our two binomials are going to have an x and a y, and an x and a y. So now we just need to figure out, okay, what is the number in front of y? Right? So it's not too scary, right, when you start doing it a little bit. So all I care about is kind of the number in front, because we've already dealt with the x squared and we already dealt with the y squared. So now we just need the number in front. So now we can just really pay attention to cab and not really be scared by that y squared and the x squared in the middle. So again, we can take our c times our a is negative 55, and our b is 6. So here, since ca is negative, that means we're going to be subtracting two numbers. And good thing b is positive, because then we can just put the bigger number in front. Okay, so what times what? Let's not worry about the negative right now. Okay, so the negative makes we're just going to subtract, so what times what is 55? Let's just worry about 55 for now, and we'll come back to the negative later. So 55, what times what is 55 but adds to 6, or subtracts to 6, right? Since CA is negative, we want to subtract to 6. So that'd be 55 and 1. Always start there. You don't have to start there, but I mean, just always remember the number and 1, right? And then 5 and 11, maybe there, right? Because 11 times 5 is 55. What about 11? Always put the bigger number first. 11 minus 5. That would be 6. Hey, there they are. So 11 and 5 are our numbers. But how do we get, since the negative is in front of the 5, then let's put the negative in front of here. Now we have negative 55, right? 11 times negative 5 is a negative 55. So there's our two numbers, and they're just going to be next to y, right? So negative 5y and a positive 11y. So positive 11y and negative 5y. And there is our factors. So it looks complicated, it looks scary, but draw the box first, separate those terms, and so go ahead and try this next one on your own. Don't get scared, just first start with this box, right, and find the sides of these two, right, this one, and then for the ends, okay? And then we'll go ahead and put negative 27 here and worry about that with cab. Okay, so just worry about the variables for now, and that will set up your two binomials, okay? And then we can deal with this negative 27 and finding your B, okay? All right, so go ahead and pause the video and you try it. So my A is 1, my B is 6, and my C is negative 27. So C times A is negative 27. So let's wait for this negative, but that lets us know that we're going to subtract the two numbers to get to our B, which is 6. And since this is a positive 6, then we don't need to worry about switching anything with that. So we take what times what is 27, come back to the negative later, and then subtracts to 6. So how about 9 and 3? 9, or 27 and 1, 9 and 3 is going to work. So 9 and 3, 9 times 3 is 27, and 9 minus 3 is indeed 6. So now the negative's in front of the 3, so let's put the negative in front of the 3 here, and then we get a negative 27. So those are going to be our numbers, 9 and a negative 3. Doesn't really matter which side you put them on. Now we can look at these letters. We have m squared is m and m, and then n squared is n and n. So there it is, m minus 3n and m plus 9n. There it is. All right, so that's it. You can pass out the homework now or start working on your homework papers. Sorry this video is so long, but I figure you probably need more explanation on it. So again, you can fast forward at any time or pause or just look at the notes.